Hi, mathematicians. In this scatter plot, each coordinate on the scatter plot represents a JCPS high school, and this data is from 2021. The x-axis represents the percentage of students at that school who qualify for free and reduced lunch. So that means that it's the percentage of families that have a lower income level so that they qualify for free lunch. And the y-axis represents the average ACT score at that school. So I took this data, I typed it into the Desmos calculator, and this is the output that I got from the Desmos calculator. So let's use the information given in order to find the equation of the line of best fit. And we know we use the equation y equals mx plus b. So instead of writing y equals m, I am going to replace the m with the number that was given to me in the Desmos calculator. Rounding isn't a big deal for this particular quiz. I'm just going to round to one decimal place, so that'll make it negative 0.2. Then I need my x and my plus. And then I am going to replace the b in the equation with the b that was given to me in the table. And I'm going to round that to 28.2. So now we have the equation for the line of best fit. So now we can find the y-intercept in the equation of the line. It's that 28.2. And what does the y-intercept represent? Well, the y-intercept represents the y variable. So what was our y variable again? Our y variable is average ACT score. So the y-intercept predicts the predicted ACT score. And I've got that reminder right there, that y variable. So that's the name of the y variable. Well, what is the y variable for the x-intercept? Well, the x-intercept again is that 28.2. So the y-intercept tells us that the predicted ACT score is 28.2 if the x variable, and what is the x variable again? Remember, the x variable is students who qualify for free and reduced lunch. So what is the value for the free and reduced lunch if my y-intercept is up here? Well, free and reduced lunch has to be 0 so that the coordinate can be up here at the y-axis. So our value is 0. So for your y-intercept, your x value is always going to be 0 because it's got to be over here at 0 for it to go up to the y-axis. So now let's look at what the slope means. And we've got our little fill-in-the-blank sentence stems for us. So the slope represents the y variable. We already know that the y variable is ACT score. And what is the ACT score doing? Is it increasing or decreasing? Well, our slope is a negative 0.2. So that means that the slope is decreasing. So it decreases by 0.2 because the slope is a negative 0.2. As the x variable, remember the x variable is students who qualify for free and reduced lunch. To figure out if it's increasing or decreasing, remember the way we read a graph? We read a graph moving from left to right. So that means that because it's along the x-axis and we're reading it moving from left to right, it's increasing. So again, it's increasing because the x-axis is going from left to right. And increasing by what value? Well, to get our rise and our run for the slope. So the rise is negative 0.2. And how do we turn that into a fraction? We just stick a 1 underneath it. So that means that our x is increasing by 1. So the slope represents that decrease of 0.2 as free and reduced lunch increases by 1. Now let's look at that correlation coefficient. And to get that, I need to go back up to my output table. Remember, we used the letter R to represent the correlation coefficient. And I'm going to round this to negative 0.95. And again, where did I get that from? I got it from the R in my table. So to figure out the strength, I'm going to refer back to the table we got when we learned about correlation coefficients. And I see from my table that anything greater than 0.80 is very strong. So 0.95 is greater than 0.80. So this is going to be a very strong, and the direction is negative because it's a negative 0.95. So our last question says, does the data prove that qualifying for free and reduced lunch causes a student to score lower on the ACT? Well, our equation is a very strong fit, so there is definitely a relationship. But there are lots of factors that relate to your family not having as much money that might contribute to you having a lower score on your ACT. Just because your family doesn't necessarily have a lot of money does not automatically cause you to get a low score. For example, if your family doesn't make a lot of money, maybe you have to have a job so you don't have as much time to study. Or maybe your family can't afford to pay money for a tutor for the ACT. So there are lots of reasons that a student might score low on a test that are related to the fact that their family has a lower income, but having a lower income doesn't automatically cause you to not do well on tests. There's a term in statistics for this. We call this correlation, not causation. It means there's a relationship between those variables, but the low income does not cause the test scores. It just is related to some circumstances that might be there because of the low income.